Hello everyone, myself Hans. Today we are going to discuss the problem of complex integration from topic line integral. Question is given, evaluate the integral, here close integral, real part of z square dz from the integral limit is 0 to 2 plus of 4i along the curve C, and curve is given by y is equal to x square. Let's solve the problem. Given integral is, this is given by closed integral real part of z square dz, and the limit is given by 0 to 2 plus of 4i, and the curve is, and the curve is y is equal to x square. First we have to draw the figure. Y is equal to x square is a quadratic function which represent parabola. So we have to draw here, this is x axis and this is y axis. We have to draw the parabola y is equal to x square, like this is the curve y is equal to x square, and this is the origin, and we can also consider the limit. This is 2 plus of 4i. This is the form of x plus of iy. Here x is equal to 2 and y is equal to 4. Point lies on the curve. So we have to write here 2 comma of 4. Point lies on the curve. And further we have to know that we know that z is equal to x plus of iy. We know that in complex integration z is equal to x plus iy, and further we can also write this is dz is equal to dx plus of I dy, and we have to find the value of here in the given integral. We have to calculate the value of z square. From here we can also write this is z square is equal to x plus of iy ka whole square. We have to open here this square. This gives x square plus of I square into y square plus of 2xy into I. Here we know that I square is equal to minus 1. So we have to write here, this gives z square is equal to x square. In place of I square we have to put minus 1. This is minus of y square, and here we have to write plus of I into 2xy. In the given integral we have to only consider the real part of z square. Here this is the real part of z square and this is the imaginary part. So we have to put in the given integral of real part. This gives real part of z square is x square minus of y square, and in place of dz we have to put in here dx plus of I dx plus of I dy, and further we have to solve the given integral. This is given by closed integral C. Here is x square minus of y square into dx and plus of I. Once again this is plus of I into x square minus of y square into dy, and this is also the integral. And further we have to solving here, we have to, let us assume x is equal to t, then from curve we can also write this is y is equal to t square. Once again y is equal to x square, then this is t square, and from here we can also find from here, this is dx is equal to dt, and from here this is dy is equal to 2t into dt, and we can also put the limit with t is equal to 0 to 2, and we have to put here the limit, this is 0 to 2, and in place of x square, here we have to, let us assume x is equal to t, so from here we get this is t square, and here is minus of y square, y is equal to t square, then y square is t to the power of 4, and this is dt plus of I, and the second integral also limit is 0 to 2. We can here also put here in place of x square, this is t square, and minus of, in place of y square, this is t to the power of 4. In place of dy, we have to put in here 2t into dt, and further we can solve the given integral. This is given by integral here, this is 0 to 2 on integration of t square dt. This is given by, we have to integrating here the first integral, this gives t square dt on integration, this gives t cube upon 3 minus on t cube minus of t cube power 4 dt on integration, this gives t to the power of 5 upon 5, and we have to putting the limit, this is 0 to 2, and the second integral we have to multiply here with t, this gives plus of I, and the integral is 0 to 2, integral limit is 0 to 2, and we have to multiply with, taken first we have to taken 2 outside, here we have to write this is 2y, this is 2y, on multiplying with t, this gives t cube minus of, and t to the power of 4 multiply with t, this gives t to the power of 5 into dt, and we have to integrating first integral, we have to put the value here, this gives, on putting the upper limit in place of t we have to put 2, this gives 8 upon 3 minus, here in place of t we have to put in 2, that is 2 to the power of 5, this gives 64 upon 5. Once again we have to calculate here 2 to the power 5, 2 into 2 into 2 into 2 into 2, this is 2 to the 4, 4 to the 8, it was 16, 6 to 32, here not 64, this is 32, and when we apply the lower limit we get the 0, and we have to solve this integral, this gives plus of 2i, and here is on integration of t cube dt, this gives t to the power of 4 upon 4 minus, here t to the power of 5 dt on integration, this gives t to the power of 6 upon 6, and we have to putting the limit, this is 0 to 2, and the next step we have to put the value of upper limit, and from here we have to solving this part. Once again we have to solving, this gives, taking LCM, this is 15, and 3 5s are 15, and 3 5s are 15, 8 5s are 40, minus of, here 5 3s are 15, and 32 3s are 3 to the 6, and this is 3 to the 9, this is 96, and plus of 2i, and we have to putting the limit here, in place of t we have to put in 2 to the power of 4, this gives 16 upon 4 minus of, here t to the power of 6. We have to putting upper limit in place of 2. This gives 2 to the power of 6. This is 64. 64 upon 6. And here we have to putting the limit. This is 0 to 2. We have to cancelling the term. 4 4 the 16. And here we have to also cancel. This is 32 to the 64 and 2 is the 6. And further we have to solve. Here we have to put the limit in our step, and further we can solve. This gives on 40 minus of 96. This gives 96 once again. 96 minus of 40. This is 56. 56 minus of 56 upon 15 and plus of 2i. When we have to solve this part taking LCM, this is 4 is a 12 and 12 minus of 32. This gives minus of 20 upon 3. Minus of 20 upon 3. And further we can also write this is minus of 56 upon 15, and here this is 22 is 40. This is minus of 40 upon 3i. This is the required solution of the given problem. Thank you class, and thank you for watching.